How do we add and subtract rational expressions? Last week we reduced and we multiplied and we divided, but we didn't get into adding and subtracting. And so we took a whole day and we just talked about finding LCMs when we have polynomials and monomials. And then how do you write fractions with common denominators? Now the reason we needed to do that, in case you have forgotten, is when you are adding fractions, so if I have 2/5 plus 3/4, and I want to add these two fractions. If you recall, to add fractions, you have to have a common denominator, because we're basically counting how many pieces do we have. Well, if the pieces aren't the same size, we can't really count them and compare them to one another. So we have to have a common denominator. And so your first goal when you are adding fractions is always to find the common denominator, write the fractions so that they have a common denominator, and then you just add or subtract the numerator. So step number 1 is to find your LCM. So for 5 and 40, my LCM is 20. And then we want to write our fractions with a common denominator. So write fractions with common denominator. That's going to be our next step. So 5 times what equal 20? Well, we must have multiplied it times 4. So if I multiplied the bottom by 4, I have to multiply the top by 4, which means I have 8. How did 4 become 20? Well, I must have multiplied it times 5. If I multiplied the bottom times 5, I also have to multiply the top by 5, and that becomes 15. After you've written them so that they have a common denominator, our third step is to add or subtract the numerator. Please realize, once you have your common denominator, that's your denominator. You're not going to change that. Make sure it stays the common denominator. So I'm going to have something over 20. What over 20 am I going to have? 8 plus 15 is 23. So we have 23 twentieths. You should always check to see if your fraction reduces, but in this particular problem, I don't think 23rd twentieth is going to reduce. And so then you have your answer. This is our process for adding fractions. Find the LCM of the denominator, write your fractions so they have a common denominator, add or subtract the numerators, and then reduce. So let's see what that looks like when we throw some variables into the mix. So when I have something like 1 over 2x plus 3 over 8. All right, so what I first need to do is I need to determine what is my LCM. So remember, first we want to deal with, when it's a monomial, we just want to look at our numbers. What is the LCM of 2 and 8? The smallest number that both 2 and 8 will divide happens to be 8. So 8 is going to be our number LCM. List any variables that we happen to have hanging out down here. We only have one variable, and that is x. And the highest exponent on x is 1. So this is going to be my LCM. My LCM is going to be 8x. So next I need to write my fractions with a common denominator. All right. So I know these two fractions are going to have 8x in the bottom. But I have to ask myself, how did they get there? What did I have to multiply them by? So I look up here, 2x, it had the x, that was taken care of. But it didn't have 8, it had 2. The only way I would have gotten that is if I had multiplied it by 4. If I had to put it on the bottom, I've got to put it on the top. What was I missing? Missing a times 4. So 4 times 1 is 4. So now I have this fraction written with a common denominator. Over here, on this one, I have the 8. The 8's taken care of. I am, however, missing the x. So I've got to multiply the bottom by x, which means I have to multiply the top by x as well. So now I have 3x on the top and 8x on the bottom, and now I have written my fractions with a common denominator. Step number 3 tells me to actually add. So I only add the numerator. That means my denominator is going to stay 8x. And up on the top, I've got 4 plus 3x, or 3x plus 4. Just add it up. Now, those are not like terms. I can't put them together, so it is going to stay a binomial. And then step number 4 is to always check and make sure that our fraction is reduced. Factor first, nothing to factor, so this is as good as it's going to get. It is reduced, and this is going to be my sum. So, found the LCM, wrote my fractions, so they had the common denominator, added my numerator, and checked to see if I could reduce. Let's do one with some polynomials, and maybe throw in some subtraction too, so we can see what that looks like. If I have 3y over y squared minus 25 minus 8 over y minus 5. This is my problem. Step number 1 tells me that I need to find my LCM of my denominators. And as we discussed the other day, that means that we need our denominators to be factored. So it looks like this one is as factored as it's going to get. Y minus 5, no common factor, that's as factored as that's going to get. This, however, is a perfect square minus a perfect square, which means that this factors to be y plus 5 and y minus 5. So now I have everything factored. When we are dealing with polynomials, remember we said you just want to list all of your factors. I have no monomials in this problem, so I'm just going to list all of my factors. So I have a y plus 5, and I have a y minus 5. I don't have exponents on any of those, so I have no exponent. So that means that my LCM is going to be y plus 5, y minus 5. So now my step number 2 is to write my fractions with a common denominator. So my common denominator is going to be y plus 5, y minus 5 for both of these fractions, y plus 5 and y minus 5. So that means I need to look at what was already in the problem. For this particular fraction, I have a y plus 5 and I have a y minus 5. I actually had both of those already. So I don't have to change this fraction. It already had the common denominator. It's going to stay exactly the same. On this one, I had the y minus 5. I did not have the y plus 5. The y plus 5 was missing, which means that I need to put a y plus 5 in the bottom. But if I put a y plus 5 in the bottom, I also have to put a y plus 5 in the top. So that means that now I have the denominator in the bottom, and if I multiply these, which means I do have to distribute, that's going to give me 8y plus 40. All right, so we figured out what we had, what was missing. The y plus 5 was missing, so that's what went up in the top. Step number 3 tells me that I actually need to do my subtraction of the numerator. Subtract the numerator. And this is where you do have to be careful with subtraction. Minus signs always cause drama. Negatives get lost, things get, forgotten. Don't forget that when we are subtracting this whole polynomial here, this whole binomial. That means it's minus 8y, and it is minus positive 40. So we are subtracting both of these. It does have to be distributed. Make sure your subtraction is being distributed. Now, as we mentioned before, our denominator is not going to change. Once you find that common denominator, it just stays the same. So 3y minus 8y will give me negative 5y. Minus 40. I have to make sure that that negative goes with it, minus 40. Now we want to double check and see if we can reduce. We always need to check and see if we can reduce. I do notice that my top will actually factor, so that's a good sign. If I factor out a negative 5, that's going to leave me with a y plus 8. And then down on the bottom, I've got y plus 5 and y minus 5. Well, it did factor, but nothing actually canceled out. So that is as reduced as that's going to get. So this is going to be my answer. I could have given this answer. I would accept this answer as well. But I had to factor it just because I needed to check to see if it will reduce, because sometimes you will find things that actually reduce. There's no way of knowing until you get to the answer and you factor it and see if it reduces. So please always double check to see if it reduces. And this is how we add and subtract rational expressions.